Welcome to Section 4, Real-Time and Historical Data Architecture. And in the first three sections, we worked on our historical database, understanding how to query it efficiently and how to manipulate data within the historical databases. However, now we're going to surround the historical database with a real-time architecture. Now you can see the architecture here, and let's just walk through this component by component so we can understand what we'll be building in this section. First, we have our data flowing in through our feed handler, and this converts the live data stream into a KDB compatible format. Next, the ticker plant, which is the key port of entry into this KDB architecture, it publishes this live data to any subscribed processes and logs the data as well. Now, the real-time database records data within tables that it gets from the ticker plant, and then at the end of the day, it will publish that to the historical database. And like I mentioned, we worked with the historical database in sections 1 through 3, and we'll be using a similar database in this section. But there's one thing to keep in mind, which is a historical database can be on disk, where we would store all of our historical data. But if we want to query that data quickly, we can bring the necessary data into memory so that we can perform fast queries upon large amounts of historical data. Now, the next component we'll talk about is the chained ticker plant. And this is just a replication of the ticker plant for redundancy, as well as to enable us to create additional subscribers like the RTE or real-time processor. In other words, our ticker plant is busy creating logs and publishing data to our RDB. A chain ticker plant then has the additional capability to publish the same data to other custom processes. This presents the core of our real-time and historical architecture, but we just need one more thing, and that's the gateway. Now, a gateway is where users can come in and authenticate and then access and query data within our HDB and within our real-time processes. So let's go ahead, pull up our notebook, and get started with this section where we'll be building out this real-time and historical architecture. So now, to begin the notebook, pip installs, imports, and ensuring we have all the resources we need, we will kick off our HDB, making sure we have that created with 2 tables, trade and quote, partitioned over a daily 10-day span. And just to double check, we can say db.tables, and yes, indeed, we have access to our quote and trade table. Now that we have our HDB taken care of, we can build the real-time architecture around it. And of course, we will start with building our schemas that will be used for the tables within our real-time architecture. So we will have 3 schemas: trade, quote, and aggregate. And as you can see, each of these tables contain the column name as well as the corresponding atomic type for that column. Now that our schemas are defined, we can start this simple tick architecture, which includes 3 key elements: the ticker plant, the RDB, and the historical database. To do that, we will instantiate our basic tick architecture using kx.tick.basic. We will create the tables, trade, quote, and aggregate for that architecture and assign ports to each of the components: ticker plant, RDB, and HDB. We will then kick off this real-time architecture. Now our real-time architecture is built. So let's see if there's any data in it. And of course there isn't, because we haven't started our live data feed yet, but we will shortly. So here we're just calling that simple tick architecture that we created, specifically the RDB, and counted how many entries were in the trade table, of which there are none yet. So let's kick off our live data feed. So there's a file called feed.py right here, and you can check it out if you're interested. Basically, we're just publishing data to each of these tables, trade and quote. And now if we come back and see how many entries or rows are in our trade table and our quote table, we see that those are now increasing and data is flowing into our RDB. But if we count what's in aggregate, we'll see there's nothing there yet because we're only publishing data to trade and quote so far. Now in the next part, we'll create some real-time analytics and APIs that can be applied to this data. And that all starts with our chained ticker plant. So what we'll be creating is a chained ticker plant as well as a real-time processor. Now remember, this chained ticker plant is subscribed to the original ticker plant and then publishes data to this processor, which will have some custom analytics on it. And what we're actually going to be doing is combining the trade and the quote tables to publish them as an aggregated table back to our ticker plant. So that's where that aggregate table that we defined earlier will come in handy. So let's start our chained ticker plant. And we will also start our real-time processor. Now within our real-time processor, we're looking to achieve three different things. First, we want to make sure that all of the information that we're taking in from our chain ticker plant are only from the tables either trade or quote. And that we will be considering our pre-processor step. In the post-processor step, we will create a function that gets aggregate information from the trade and the quote table and puts it together to be published back to the primary ticker plant. And then that ticker plant will publish that newly aggregated table into our real-time database. So we'll define our preprocessor function here, which checks and makes sure any information coming in is only from our trade and quote table. And then our post-processor. So this is where we take some of the information from the trade table, some of the information from the quote table, merge that together using a left join, create an extra timestamp column there, and reorder the columns in a way that we want to publish them to our ticker plant, store them in a dictionary under the aggregate key, and then simply publish this back to the original ticker plant. So that is the post-processing function. Now that the pre and post-processor are defined, we can prepare our real-time processor to be started to act upon this live data. All we have to do is just register the pre and post processing functions and include the libraries necessary to run these functions. So in this case, we'll need PyKX to run those pre and post processor functions. And after all that, we can go ahead and start that real-time processor. Now, data should be being published back to our aggregate table within our RDB. So let's go ahead and check. And yes, we see data is flowing. Next, we'll add a query API across both real-time and historical data. And this API is going to calculate the number of trades that take place for a specific symbol. Now, we'll create two functions to do this. First will be for the real-time processor, and this means this function will be enacted upon real-time data. One of the powerful aspects of PyKX is that you can use SQL-like syntax to create queries if you're more comfortable with SQL. And to do this, simply use kx.q.sql and put our query in, which calculates the number of trades that happen for a given symbol within the real-time processor. Now for the historical database, we'll create a function that's slightly different. The function will take in the symbol of interest as well as the time span, or the number of days, that we want to calculate the count over. Now it will calculate the number of trades for a given symbol over that chosen period of time. Once we have both of these functions defined, we can then register them as APIs. Now to register as an API, RTE, which is our real-time processor, register_API, and we give it the name of that function and a custom API name called custom RTE. And we'll do the same for the historical database, and we need to make sure that our HDB also has access to the PyKX library. We'll register our custom HDB query to our HDB using register API and call it custom_HDB. Let's test this out. We'll go ahead and connect to our real-time processor on 5014 and call that API that we just defined, passing it Google as our symbol of interest. And we see that in this real-time processor, there are 278 times when there was a trade involving Google. Now let's try it on the HDB. In this case, we'll look at Google again, and we'll look back 2 days. And we see there's over 3,000 instances where there was a trade with Google in this case. So here we were able to create 2 APIs, one for real-time data, one for historical data. Add those as APIs available upon both the real-time processor and our historical database, and test them out to see that they're working correctly. The last part of our real-time architecture will be adding a gateway. And this gateway is going to allow us to query across both of those real-time and historical databases. What we'll do first is define a gateway function. And this is pretty interesting because this is going to, in one function, allow us to query either just the real-time data or actually combine insights from real-time data and historical data. So as you can see, we'll pass in the symbol of interest as well as the number of days back we would like to look. We will call that custom RTE API that we just created. And remember, all this is doing is counting the number of trades for a given symbol within the real-time process. But if we pass in the number of days that is greater than 0, that means we need to go and check out the HDB as well. We need to understand how many times there's been trades in the historical database given that symbol. So that means we'll go ahead and call the custom HDB function in the case where n days is greater than 0. Now finally, at the end, we'll actually combine them. So we'll add the RTE number of trades and the HDB number of trades together to get our final number of trades, which covers real-time data and historical data all together as one. Additionally, we'll define a function enabling us to do some basic authentication. We'll then go ahead and start our gateway using kx.tick.gateway on port 5015. We'll need our PyKX library as well as give it access to the gateway function API that we just created above. And we'll need to connect it to the HDB as well as that real-time process. And then we'll use our user validation for our connection validator. And gateway.start to kick off our gateway. And after this is complete, we will have built out our entire real-time architecture. So that concludes section 4, which is quite an exciting section where we will be able to build an entire real-time and historical tick architecture. Now moving on to section 5, we'll be building upon this architecture with a bit more complex queries and APIs. So I suggest moving right into section 5. In fact, section 4 and 5 are a part of the same notebook. But if you have to step away and then come back later to section 5, you'll have to rerun the entire notebook starting from section 4, and that's just so you can build out this architecture again, which will be continue to be built upon in section 5. All right, thank you, and we'll see you in section 5.